Hello everyone. So today let's solve the problem number 417, Pacific Atlantic water flow. So let's see what the question states here. So we have been given an m into n height grid. So you can clearly see here by looking at the diagram. Yeah. So we have been given an m into n height grid. Water can flow from the cell to the neighboring this one, whether it may be up, down, uh, this one, north, south, east, west, we can consider, right? So in simple terms. So if the neighbor's height is less than or equal to the current height, if the neighbor's height, suppose this is the, suppose this we have considered 3 actually, just give me a second here. Yeah, suppose if we have considered 3 here, so if the neighbor's height is less than or equal to current height, less than, so here 2 is less than 3, right? So 3 we have considered and the neighbor is 2, 2 it is less than or equal to the current height, right? So neighbor, we can consider left, right, this one top or down. So I've just considered left here. So if the neighbor's height 2 is less than or equal to the this one current height, then the Pacific touches the top and left edges. The Pacific this one touches the top and left edges. So here it is 2. Then we will check with the 2. 2 is less than or equal to 3. No, actually it is greater than, right? So this fails actually here. This fails the conditions. It will not touch the this one Pacific actually. Yeah. So in the same way here, you can just consider this one actually 3. So 3 will consider, if we consider 3, suppose only 3, right? We don't have any condition. Suppose if we directly consider 3, 3 here it is less than or equal to 1 is less than or equal to 3 actually, right? So next it touches the Atlantic here, right? So see, uh, if the neighbor height is less than or equal to current height, the Pacific touches top and left edges, the Atlantic touches bottom and right edges, right? So we have to return all the coordinates where water can flow to both oceans. We have to return all the coordinates where water can flow to both oceans, right? This one we have to keep in mind. Yep. So let me delete this one. The only condition is the considered cell, whatever the cell that we consider actually, this one, the next neighboring cell has to be, or the neighboring cell's value has to be less than or equal to the current cell, right? In that way, we have to go on checking, and if it comes at the end or the edge, actually, so if it is less than or equal to the this one, previous one, or the current one that we are considering, actually, then it will touch the Pacific or the Atlantic, top or the bottom ones. Yep. So this is fine, I believe. Yep. Now let's do one thing. I hope the question part is completely clear. Now, before this one, what do we call? Before hopping into writing the code, actually, let's discuss the approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So here, one thing I want to tell you here is we will be going with a BFS actually. We can also call this one as a reverse BFS, right? So we will be going with a BFS also. We can just call this one as the reverse BFS, right? So by reverse BFS, let's check the same here. First, let's consider the same first example here. So let me delete this one. Yep, let's consider the same example here so that we can see the diagram as well. Yep, this is fine. So here the output that we need to get here is this one. 1 second, just give me a second here. So first thing we are going with a BFS, or you can just call this one as reverse BFS actually. I'll just write this one, reverse BFS, solve this problem. First, let's consider the same first example for the this one. What do we call? Mm, for the approach actually, right? So first what we'll do, see here, we will treat the grid as group of cells. Yeah, so this is group, this is one cell, this is one cell, this is one cell. Yeah, we'll start from the usually 0 comma 0. Will this one 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4. Same goes with 1 comma 0, 1 comma 1 up to 1 comma 4, 2 comma 0 to 2 comma 4, 3 comma 0 to 3 comma 4, and finally 4 comma 0. So this one actually 4 comma 0. So this one is the final one is 4 comma 4 here, right? So this is fine. So we'll treat the grid as graph of cells. Instead of pushing water outward, we will reverse the flow. So that is the reason I said we'll be going with a reverse BFS. Listen to this carefully. We will reverse the flow and we will start the BFS from the ocean borders inward. We'll start the BFS from the ocean borders inward, right? From the Pacific border cells and Atlantic border cells, from the Pacific border cells and the Atlantic border cells, right? For each ocean, what we'll be doing, we will run the BFS. For each ocean, we will be running the BFS, right? For from a cell that we can go to the neighboring cell, or we can go to the neighbor if the neighbor's height is greater than or equal to the current cell. See, we are going with the reverse BFS instead of checking for the less than or equal to the current. So what we will do, if the neighboring height, so here for each ocean run BFS from a cell, we can go to the neighbor if the neighbor's height is greater than or equal to the current cell height, right? Because in the forward flow, water would flow from neighbor down to current, right? So then we will mark all the visited cells from each ocean, right? So intersection of two visited cells is equivalent to the cells that can reach both the oceans, right? So let's come with the example. Let's consider this example itself. We'll start the BFS from the Pacific, right? Top row plus left column, and the Atlantic bottom row plus this one, what we call right column actually. Yeah. So this is we'll start here, this one, this one, right? So we'll start the BFS from the Pacific, nothing but the top row plus left column, and the Atlantic bottom row plus right column, right? In the example, BFS from the both this one boundaries mark cells such as this one 0, 4. So this one. So this is at the edge. It will directly flow. So this is nothing but the 0, 4. So this is fine. Then comes to this one connected to both by non-increasing paths actually. Yeah, 0, 4 connected to both by non-increasing paths, right? So this is one thing that we consider actually. This is one of the cell 0, 4. Yep. So this is fine. Next, what we will do next, connect to both by non-increasing pairs. So this one next comes 1, 3. So see here 1, 0, 1, 2, 1, 3. So this one actually 1, 3, right? So 1, 3. Next we will check whether that is greater than or equal to 4. Yes, this one also actually 1, 3, 1, 4. These two things we can include this one as well, right? So this one will be 1, 3, 1, 4. Instead of less than or equal to, we'll be going with a greater than or equal to here. Next comes the 2, 2. 2, 2. So this one 2, 0, 2, 1, 2, 2, right? So this one actually. Yeah. So we'll check whether what we'll do, we'll check for the next one, right? So here 5, it can directly go. 4, we'll check whether it is less than or equal to the neighbor one. So it is lesser here. So we'll go to this one and we can just go to this one. We will be considering 1, 3 as well as 1, 4. This one 1, 3, and we will be considering 1, 4 as well. This is also fine. So next we'll consider 5. 5, see here, this one actually 4 is less than 5. Yes. Then we'll check this one 4 is less than 2. Yes. So it can go to the Pacific Ocean as well. And here Atlantic Ocean 5 is less than 3. Sorry, 3 is less than 5. Yes, it is. 1 is less than 3. Yes, then it can flow here as well. Right. So then we will consider 5. So this one 5. Basically, it's 2, 2, I believe. Yeah. So let's add this one as well, as it can flow to both Atlantic as well as the Pacific. Next, we will be considering 3, 0 actually. So this is nothing but 3, 0. All other cells that we have this one ignored, this cannot be actually. This cannot be. This cannot be. Yeah. So don't get confused here. Yep. So this is fine. Now we will go with this one. What do we call 3, 0. 3. This one also cannot be. This cannot be. This cannot be. This also cannot be. So let's not consider this one. This we cannot. This we cannot. This we cannot. Yep. So now we will be going with a 3, 0. So see here 3, 0, 6. It can directly, right? So this one actually, and it can go. See, we will check whether 5 is less than 6. Yes, 5 is less than 6. So Pacific as well as the Atlantic, right? So this one we can. So it flows to both Atlantic as well as the Pacific. So we'll add this one as well, 3, 0, right? So next 3, 1. So here we will check this one, 3, 1. So it can flow to this one. See, 1 is less than 7 and Atlantic Ocean, and 6 is less than 7 and directly Pacific Ocean as well. Yep. So this is also possible. This is also possible. So we will add 3, 0 as well as 3, 1 here, right? So this is also fine. Next, we will check for the this one. What do we call? This one fails actually. Yep. So because see, 7 is not less than this one. 7 is not less than 1. 5 is not less than 1. 4 is not less than 1. It can go to, it can flow to Pacific, this one Atlantic Ocean actually, because 1 is less than or equivalent to 1. Yeah, 1 is equal to 1. It will flow to Atlantic Ocean, but for the Pacific Ocean, it doesn't flow to Pacific Ocean. So we'll not consider it. Same thing happens with this one as well, this one as well. Yep. Next, we'll go with a 4,0. Right. Next, we'll go with a 4,0. It can directly, right? So it can directly flow into this one Pacific Ocean as well as the Atlantic Ocean. We can consider this one as directly, right? So 4,0 as well. 4,0 as well. Yep. So this one fails because it can only to the Atlantic Ocean. This one also fails as it can only to the Atlantic Ocean. I can just check. So see, one it can flow directly, but one is less than or equal to one. Yeah. Next, 5 is less than or equal to one. No, 5 is greater. So the same thing happens with 2 as well. Same thing happens with 4 as well, because 5 is not less than 1 here in this case. This is fine. Yep. Now, what are the this one accordingly with the condition that they have given in the question? What are the cells that can flow both to Atlantic as well as the Pacific Ocean? This one 5, 4, 4, 5, 7, 6, as well as this one as well. This 5. So the cells are 1, 0, 4 actually. This one 5 actually. 0, 4, 1, 3, and these two 4, 4. 1, 3 and 1, 4. And mid one, the 2, 2. We have checked this one. Yep, this one 2, 2. Then comes the this one 3, 0 and 3, 1. So this one 6, the value with the 6 and 7, and finally the 5. This one the cell 4, 0. Yep. So these are the cells basically. Yep, these are the cells. See, these are the cells visited by both BFS runs actually. Yep. So this one actually will be checking whether will be running the reverse BFS if the neighbor site is greater than or equal to the current cell, right? Because in the forward flow, water would flow from the neighbor down to current, right? So we'll mark the visited cells from each ocean. So let's uh, this one. Let's try to implement the same thing in the form of code. Yeah. It will be nothing. Let's move on with this thing actually. What do we call complexities part? As we are completely familiar with the approach actually, so we got 0, 4, 1, 3, 1, 4, 2, 2, the same thing, 3, 0, 3, 1, and 4, 0. The output that we got here, basically the output that we got matches the output that they have given for the example one within the question. So our approach works absolutely correct here, right? So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here in this case? So the time complexity would lead to big of m into n, right? So the time complexity would lead to big of m into n. So what would be the space complexity here? The space complexity would lead to big of m into n as well, right? So why the time complexity here is big of m into n? Because each cell is visited at most a constant number of times across the two BFS runs. So overall time complexity would quite obviously lead to big of m into n itself. Yeah. So the space complexity would lead to big of m into n as well, because we'll be making use of the visited arrays and we'll be going with the BFS queues. As BFS uses queues, we'll be going with the BFS queues in the worst case. So it would lead to big of m into n as well. The time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss. Let's start writing the code actually. Yep, the first thing here would be to handle the trivial null or empty input, right? So we have to result list to return basically. So I'll just go with the list here. List of list, it consists of the integer. So type integer, this is fine. Let me make this one capital A. Yep, so this is fine. Let me consider the resulting variable array as new array list. Yep, so this is also fine. Yeah, the next part would be let's write the simple if condition here. If height, let me copy this one. If height is equivalent to null, or um, height, length of the heights actually, if it is equivalent to 0, or uh, heights of 0, this one, dot length, if it is equal to 0, then we have to just return the resulting variable res. So this is fine. Next, let's go with the number of rows and number of columns. So this one will be int m equals this one. What do we call? Heights dot length. So this is fine. Int n equals So this one height, so 0 dot length. This is fine. Yeah. Now let's do one thing. Let's go with the visited cells that is reachable from the Pacific, as well as let's go with the visited cells that is reachable from the Atlantic. So let me go with Boolean here. So this is fine. Pacific visited. I'll just consider PSC visited equals new Boolean of size. Let we have to go with the M and N grid, right? So M into N respective. Let me copy the same thing for the Atlantic visited as well. I'll just keep here instead of PAC. Let me consider this one ATL, nothing but Atlantic. So let me make this one capital B, also this one as well, capital B. Yep, so this is fine, man. Now, let's go with the BFSQ. We have to make use of the BFSQ for the Pacific as well as the Atlantic. So let me go with the DQ here. So, yep, so this is fine. Int array. Let's do one thing. I'll just go with the Pacific Q here. This one capital Q equals new array DQ. This is fine as well. The next one is, let me copy the same thing and make the necessary changes for the Atlantic. So I'll just go with ATL for the Atlantic Q. So this is fine. We have successfully made use of the this one BFSQ for the Pacific as well as the Atlantic. Yep. So now let's do one thing. What shall we do after this? So let's initialize the Pacific queue with the top row and the left column. So let me write it on this way. Let's move on with the iteration part man in simple terms. So this will be int I equals 0. Sorry. Yeah. I less than m. So this will be I plus plus. Also within the for loop, let me go with the Pacific queue. This one. Yep. So let me copy this one and make the necessary changes. Dot offer. So this is fine. New int of, yep. So let me pass here I comma 0. Yep. So this is fine. This is fine. Yep. Now let's do one thing. Let's mark visited for the Pacific as well. So I'll just go with Pacific uh visited I this one 0. Let me set this one to the Boolean value. Yep. So we are just marking the visited for the we are just marking visited for Pacific actually. Let me come out of this one entirely. Now let's do one thing. Um, let's iterate the columns now for the same thing. J equals 0. Let me type this one quickly actually. So let me go with the J plus plus here. So I'll just go with the Pacific Q, the same thing actually. So this one will be Q dot offer. Uh, So let me do one thing here. Let me copy till here actually. Yeah. So let me paste it over. Mm, paste it over here. Right. So this is fine, man. Uh, so here dot of new int. So this remains same actually. Instead of the I comma 0, we'll be going with a 0 comma j. And also instead of the this remains same, I believe. Specific visited actually, as we are considering for the columns actually, as we are iterating through the columns, this becomes 0 j, and this one will be setting this one to true itself. So we are going with the left column to specific, this part. Now we are going with the top row to the Pacific, so this part actually. Then we are marking visited for the Pacific, right? So marking visited for the Pacific, this is fine. mm, for loop we are ending here, so one more extra I have added, I believe. Next, let's move on with the further things here. So let's initialize the Atlantic queue with the bottom row as well as the right column. Yeah, so let's move on with the for loop here. Again, one more iteration. So let's initialize the Atlantic queue with the bottom row and the right column. How can we do this one? For I equals 0, I less than m. So this will be I plus plus. So within the for loop, so let me go with q. Q dot offer. So this one will be new int. So this is fine. This will be I comma n minus 1. Yep. So this is fine as well. Yeah, right column to the Atlantic. Next one, we'll mark the visited for Atlantic. So I'll just go with here. After this, Atlantic visited. So this one will be quite obviously I into n minus 1. Let me set this one to true initially. Yep. So let me do one thing. So let me copy the same thing actually here entirely and let me paste it over here. Make the necessary changes. So this one will be, we are considering this one for the columns, right? For the Pacific, Atlantic, sorry, j equals 0, j less than n, and j plus plus. So this remains same. Yep. This one Atlantic Q dot offer new int. This remains same. Instead of I comma n minus 1, so we will be going with a m minus 1 and j, right? So we will be going with a m minus 1 as well as the j. Yep. So this differs actually as we are going with the bottom row to the Atlantic and marking visited for the Atlantic as well, right? So this one Atlantic visited, this remains same. So the variable remains same, m minus 1 into j we are considering, right? M minus 1j, we are setting this one to the true. So this is fine, man. Let's come out of this one. Now let's do one thing. Let's run the BFS from Pacific border cells, nothing but reverse flow rule. We can move to the neighbor only if this one. So what's the condition here? Sometimes I forgot. So I'll just give me a second here. We are just going with a reverse flow rule, right? So this is we can move to the neighbor if neighbor's height is greater than or equal to the current. So reverse BFS, this one rule. So we discussed this one within the approach itself, right? So only if the neighbor's height is greater than or equal to the current. Yeah. So how can we write that one in the form of code? Let's check the same here. Yeah. So how can we write this one? 1 second. Give me a second here. So now let's do one thing. I'll just go with a BFS of, let me go with height. Sorry, what did I do, man? So let me copy this one here, height. So I'll just come here. Let me pass the heights here. Also, Pacific Q. This is fine. Also, let me pass this one, Pacific visited actually. So let me copy this one. Let me paste it over here. And along with this, let me pass M and N respectively. Yep, so this is fine. So the next part is we have to run the BFS from the Atlantic border cells. So I'll just go with BFS of here. So let me paste this one. Let me copy and paste this one. Hi. So this is fine. So this time Atlantic Q, right? So let me copy this one. Atlantic Q. Next Atlantic visited. Let me copy this one. Let me paste it over here. So this is also fine. And let me go with a M as well as N. Yeah, so this is fine. So the next part would be we have to collect the cells that are reachable by both Pacific as well as the Atlantic, right? So let me go with the two for loops here. So this one will be int I equals 0, I less than M. Let me increment the I. And one more for loop. So this one will be for int j equals 0, j less than N columns. So this is fine. J plus plus. As we are collecting the cells that are reachable by both this one Pacific and the Atlantic BFS, right? So let's write the simple if condition here. If Pacific visited, where is it? So let me copy this one, Pacific visited. If Pacific visited of I as well as the J and this one, Atlantic visited, again same thing, IJ, right? The cells are visiting both actually accordingly with the condition, then we have to add as row comma column. We have to add the cell, right? So we will be adding that one as row comma column. So I'll just go with result dot add of arrays dot let me make use of the as list operation, row and column meaning I comma j here. Simple, very simple. Let me come out of this one entirely. Now let's do one thing. let's return the result. In the sense, we have to return the intersection list here. So I'll just go with the return result. Yeah. So let me come out of this one entirely now. Now, let's go with the BFS helper method, man. Let's go with the BFS helper method. So here, see, I have made use of the BFS directly here, helper method. So we haven't written the this one BFS helper method at all. So I directly wrote. I was thinking some other thing, I believe. So I would have stopped here. First, write this one. First, write the BFS helper method. Then we would have continued with the same, right? So this is fine. I have already written the BFS helper method and this one. So we are left with only one thing, meaning we have to write the BFS helper method. For let's continue writing that one, right? So let me go with private void BFS. So this one will be int heights. So not this one. Let me consider copy this one, paste this one. Then let me go with the DQ here. So this one will be int. This is also fine. Q and boolean, this one will be visited, so this is fine. Int m int n, so this is fine. Yeah. Now within the helper method, this one, what do we call BFS? First thing, let's consider direction vectors for this one. What do we call north, south, as well as the west and east, right? So I'll just write here, and we know this one how to write. So this is nothing but directions, DIRS. So new int of so this is fine. Give two arrays here, so this is fine. Let me go with first -1, 1. Sorry, 0 we have to go with, right? 0, 0, -1 for the column, actually 0, 0, -1 and 1. For this one, -1, 1, 0 as well as the 0. So we have to combine both -1, 0 for the first one. Okay, fine. For the next one, we have to go with a 1, 0. This is fine. For the third one, we have to go with a 0, -1. So this is also fine. And for the fourth one, we have to go with a 0, 1. Yep, this is also fine. Now let's write the standardized BFS loop, man. So I'll just go with a while or q dot is empty. Right, well, q is not empty actually. So first we have to pop the front actually. So if you know the BFS, right. So this one I'll just give cell equals. Let's make use of the pole here. So I'll just go with the q dot pole. So this is fine. Yep. Now this is fine. Now let's go with the row index as well as the column index. So this one will be int r equals cell of 0 and also int c equals cell of 1. Yep. So this is also fine. The next part would be we have to explore the four neighbors. Nothing but let's go with the for loop here. So this one int d of directions. So this is fine. So int nr, this is equals r plus d of 0. Yep, neighboring row, fine. Let's consider the neighboring column now. nc equals c plus d of 1. Yep, c plus d of 1. Nothing but the neighboring column here. Now let's check the bounds actually. For checking the bounds, I'll just go with if nr less than 0, neighboring row less than 0, or neighboring row should not be greater than or equal to row as well, right? So that is also related to the bounds itself. This is entirely related to the bounds itself. M greater than or equal to m, or neighboring column shouldn't be less than 0, or neighboring column shouldn't be greater than or equal to the column size or n, right? So then if it is, then we have to skip. I'll just make use of the continue keyword. Now, if the cell is already visited, then we have to skip. In that case, I can just write it in this way. If visited of nr as well as the nc, this is fine. Then let me give continue keyword. Yeah. So let me skip here. Nothing but let's make use of the continue keyword. Yeah. So now let's go with the reverse flow condition. Let's go with the simple if condition, man, here. So if heights of nr as well as the nc neighboring row and neighboring column, if it is less than heights of row as well as the column RC, then also we have to skip. In this case, I'll just give continue keyword. Finally, we are left with only two things. One thing actually, we have to mark visited and we have to push the neighbor. For marking the visit, this one, for marking as visited, I'll just go with visited of neighboring row as well as the neighboring column. Let's set this one to the Boolean value true. And for pushing the neighbor, let me make use of the offer keyword. So this is fine. Of new int of, let me keep here nr comma and see neighboring row and neighboring column. Yeah. So this is it for the code one. Simple one. Yeah. So yep, this is it for the code. Let me format the code once. So code might seem little bit lengthier, but the same thing, man. Just we'll just this one, right? This one, the base condition, and Pacific visited this one. Atlantic visited Pacific queue and Atlantic queue because we are making use of the BFS. These are the two BFS queue actually, and this is for the visited ones, right? So this is fine. Now the same for loops actually, if you know. So this is for the Pacific queue, Pacific visited rows and columns. This is for the Atlantic queue and Atlantic. Uh, this one, yeah, Atlantic queue as well as the Atlantic visited here for the rows as well as the column. Same thing. Then we are writing the helper method BFS here. You should be knowing the BFS, right? This one directions, right? North, south, east, and west, right? Directions. Then the standardized BFS loop. If you know the BFS algorithm, you would be able to write the BFS here. Uh, then we are making use of this helper method BFS within the this one as we are going with the BFS, right? So we are going with the reverse BFS actually. We are checking with greater than or equal to, if you remember, right? So we are passing this one. We are going with the BFS actually twice here. Then we are checking if what are the cells that can flow into both this one Pacific as well as the Atlantic Ocean here, right? If Pacific visited of IJ and Atlantic visited of IJ we are considering. Then finally, what we are doing here, we are just uh, basically what do we say? We are just adding as row comma column here for this one, right? Array as list of I comma j. So this is fine. The result is nothing but we are just returning the intersection list, meaning so the what are the this one cells that have uh, the ability to flow to both this one. What do we call? What are the values? Basically, we are just going with the cell numbers, right, rather than the values that are present in the cell. So we are displaying the cells that can flow both into Atlantic as well as the Pacific Ocean. Yeah, that's it actually. Yep. So this is fine. So now this has to work. Let's see. Let me hit the run button. Yeah. Mm, So this one I haven't mentioned the arrays here. Line number 78. Finally. So we are going with a new int. This is fine. Yeah, I haven't mentioned the array here. So this one I have to mention the array. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly, man. I hope this works for all the test cases actually. I hope. Let's see. So here you can clearly see all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. This is simple one. Yep. So this is fine. So I hope again the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.